Okay, good morning everyone. So myself Devabrata Kumar Das from Dumka Engineering College. Today we will take the subject process instrumentation and control. And topic is control valve and their assembly instruments also.
Am I audible? Please confirm me anyone. Am I audible or not?
Yes, sir, you are audible.
Okay. Okay. So very good morning, all of you. So we have discussed in our last classes. This is the control valve. Okay. And in corresponding view, we have to also discuss basic characteristics of a control valve, and also we have to classify different control valves. Okay. And also we have to discuss the different symbols of the control valve. Okay, so these are the basically classification control valve. First, we have to classify into two categories: linear motion, and another one is a rotary motion. And then this linear motion, it is also classified according to their application oriented different categories. This is globe type of linear motion valve, and also diaphragm or pinch or clamp type of valve, and also this is also three-way globe valves, and also three-way, four-way. These are the basically application-oriented different types of control valve we have to classify. And another one is angle type of control valve. Okay, this globe valve. It is also classified into these categories: single-seated, double-seated, and split body also. So these are the total classified in the linear motion control valve. And this rotary motion control valve, it is also classified into these categories: butterfly type of rotary motion control valve and ball type of rotary motion control valve. This butterfly or eccentric plug type of control valve, it is also classified into these categories, that is swing type of control valve, lined or eccentric type of control valve. And this ball type of rotary motion control valve, it is also classified these three categories according to their application oriented. So this is segmented. Another one is the full and also V notch type of control. So this type of control valve we have to discuss, and we have to see in the different symbols of the control valve in the previous classes also. Another one, this is also different types of symbols of the actuator symbols. Okay, so and previous slide we have to discuss, that is the different symbols of the control valves. Okay, so there you can see this is the basically general symbol of the control valve. This is angle type of control valve. This is butterfly type of control valve symbol. This is rotary type of control valve symbol. This is globe type of control valve, three-way, four-way, and so on. So these are the different symbols it is we have to discuss in our last classes. Then we have to also follow discuss that these are the basically different types of control valves we have to discuss in previous classes. Okay, this is a butterfly type of control valve. Okay, this is the basically angle type of control valve. Okay, this is the diaphragm type of control valve. This is a three-way. This is a three-way control valve, and so on. Now, today we will discuss this control valve assembly tools or supporting instruments. So, this control valve, it is assembly typically consists of the valve body, okay, and the internal trim parts and actuator to provide the motive power to operate the valve. So first of all, we have to know in previous classes what is the basic material we have to make the control valve or their bodies also. So in this application oriented, this control valve we have to make using the different material. That is, sometimes it is also aluminium, sometimes it is also stainless steel, sometimes it is also bronze type material, sometimes it is also used, that is PVC, polyvinyl chloride. Okay, sometimes it is also nickel material or any other etc types of materials we have to make for the control valve. Okay, so in a control valve, there are another instrument we have to attach in this total system. So here in this picture, here you can see this is the basically one application oriented control valve, and this valve here the main instrument we have to connect it, that is a valve actuator. Okay, and then we have to also positioner system. These are the basically valve body, where these are the basically two-way system. One is the inlet input. Another one is the output section. Okay, inlet and outlet also. Another one is the valve state. Okay, so these are the main instrument or main apparatus which is totally control valve. So this control valve assembly is typically consist of the valve body and also internal trim parts also, and actuator, that means the valve actuator is to provide the motive power to operate the valve. So I will discuss one by one again since broadly. So first, valve actuator. So actuator, what is actuator? Anyone please tell me what is valve actuator or what is actuator? So actuator, it is a basically one device that produce a motion by the converting energy, and it is also signals going into the systems also. So this valve actuator, it is basically one device which is produce a motion. Okay, that means produce a one vibrations type of motion or any other type of that is movable part. So this actuator, it is a device that produce a motion by converting energy or signals going into the system. So this motion, it is produced, it can be either rotary type of device or linear type of device. So we have to classify this valve category into two categories. One is the linear operation, another one is the rotary operation. So this motion, it is basically produces, can be either it is linear type or another one is a rotary type of motion. This actuator, it is a device that produce a motion by converting energy and signal going to the system. So this is called the actuator. And this actuator, it is a basically we have to discuss, it is broadly classified into three categories. One is the electrical actuator, another one, number two, that is pneumatic type of actuator, another one is the hydraulic type of actuator. Okay, this part is clear, all of you? I am repeats once again, what is actuator or valve actuator? This valve actuator, it is a device that produce a motion by converting energy and signals into the system. And this motion, it is basically two types, either it is rotary type of motion or another one is a linear type of motion. So this actuator, it is a device that produce a motion by converting energy or signal going to the systems also. Okay, and this valve actuator, it is basically classified into three categories. One is the electrical type of valve actuator. Number two, pneumatic type of valve actuator. Number three is hydraulic type of valve actuators also. Okay, is it clear, all of you? Please respond me. Is it clear what is valve actuator? Jatin Kumar Jha, MD Talib Ansari, Rishabh Pushkar, Shivam Jaswal, Sanu Kumar Maran. Please respond me. It is clear. Are you hear me? Am I audible? Sonu Kumar Marandi, am I audible? Okay, so this electrical, these are three types of valve actuator. Okay, it's electrical type or pneumatic type or hydraulic type of valve actuator. And this actuator, what is the basic examples of different types of valve actuator? So in our process control industries or any industries, we have to uses this actuator in different parts of the any device or system. So this actuator, it is a part of a device or machine that helps to achieve the physical movement by the converting energy, or this energy, it is either it is electrical signals or air, that is a pneumatic, and another also hydraulic power, and into this energy it is converted into the mechanical forces. Okay, and what is the basic examples of these actuators? So you have to use that is electric motor, different types of motors, that is stepper motors. Okay, and another one is jack screw systems, electrical muscular stimulator systems, or any robotic systems. So these are the basic application area of the valve actuator. So this valve actuator, we have to use as different systems, that is electric motors, stepper motors, jack screw systems, electric muscular stimulator system, or robots arm systems also. So these are the basically basic application of the actuators also. Okay, so in this actuator part, there are another components we have to attach in this actuator system. That is the drive system, comp drive system, hydraulic piston. Here one piston it is also present. Electric type of motor we have to use this. Relay system we have to use this. Thermal biomorph it is present. Digital micrometer. Okay, piezoelectric actuator, electroactive polymer. So these are the basically different components which is attached in this valve actuator system. Okay, so this is the basically little bit idea of the valve actuator. What is the basic definition of the actuator? What is the basic classifications of the actuator, or application? What is the application area of the actuator system? Then next one, that is the positioner system. Okay, so this positioner, here you can see this device, it is called the positioner system. So this is a, sometimes it is also called valve positioner. So this positioner, it is used for pneumatically operated valves that depend on a positioner to take an input signal from a process controller, and it convert into the valve travel system. So this positioner system, which is connected in between the actuator and also the valve stem, as well as also valve body also. So this positioner is used for pneumatically operated valves that depend on the positioner to take of the input signal from a process controller, and it convert into the valve travel also. So this positioner, it is help for the travel for the linear motion or rotary type of motion energy from this division, that is the actuator division, to the valve body also. Okay, so we have to know this positioner system is mostly available in three configurations also. One is the pneumatic configurations positioner system, number two analog input type of positioner system, and number three is the digital type of positioner system. So please remember these things also. These are the basically classification of the positioner system. So according to our application oriented, this positioner, it is also classified into three categories or three configurations. Number one is the pneumatic type of positioner system. Number two, analog input type of positioner system. Number three is the digital type of positioner system. Okay. So in this pneumatic positioner system, here the pneumatic signals, it is basically uses the one parameter, that is the 3 to 15 psig. Okay, so these are the basic parameter unit we have to use as this pneumatic type of positioner system, and it's supplied to the positioner system. Okay, and when the analog input type of positioner system, we have to perform any valve, control valve system, it performs the same function as in the above we have to discuss, but it is uses electrical current, it is ranges is 4 to 20 milliampere instead of the air as the input signal. Okay, you have to easily discuss, easily you have to understand that when you have to uses the pneumatic type of positioner system, in this case the air pressure we have to control for the input section, and the unit is 3 to 15 psig. Okay, so these are the basically supplied of input pressure from the actuator to the positioner system. And when you have to use the analog type of analog input type of positioner system, this positioner, it is perform the same to same pneumatic type of positioner system, and here it is uses the electrical current, range is 4 to 20 milliampere instead of the air pressure. And another one is the digital. Okay, so this digital input type of positioner system, it is basically same function as well as the analog input, and as well as also pneumatic type of actuators. Here we have to use this 0 and 1 concept also. Here 1 is the on condition and 0 is the off conditions also. And here this digital communicating system we have to attach in these systems also. Okay, that is a transmitter and receiver circuits we have to attach in this digital positioner control system. So these are the basically positioner systems. Okay, is it clear all of you what is positioner? Please respond everyone. Is it clear or not? Is it clear? Alok Prakash? Alok, Jatin Kumar Jha, MD Talib Ansari, Rishabh Puskar, Shivam Jaswal, Tanu Kumar Marandi. So please respond everyone. Otherwise, you are all present in class because, but I am.
Yes, sir.
Okay, so please respond everyone. So is it clear what is the valve actuator, what is the basic application of valve actuator and positioner systems also? Okay, so next that is the one is the valve stem and another one is the valve body. So what is the valve body? Okay, here you can see these are the basically device of the valve body. One is the input terminal, another one is the output terminal. So this valve body, it is one of the pieces of the equipment which is allows the automatic transmission functions is correctly. So when we have to use this system, this configuration, so fluids or any types of liquid flow, it is controlled by the positioner system, which is connected through the actuators also, and the liquid is fluid flow, it is speed control we have to attach in this inlet or outlet valve also. Okay, so these are the basically valve body, and this valve body we have to make different types of material. We have to discuss that is a aluminum type of material, bronze type of material. Sometimes it is also PVC, polyvinyl chloride type of material. Okay, sometimes it is also stainless steel type of material, tungsten type, nickel type. So these are the different material we have to uses. We have to make the valve body also. Okay, so this valve body, it is a connected to the positioner system, and another one is the valve stem. What is valve stem? So this valve stem, it is a, self-contained valve which opens to admit the different types of gas to a chamber, and then it is automatically closed and kept sealed the pressure into the chamber. So this valve stem, it is basically uses, it is connected between the actuator and positioner system, and it is also a self-contained valve which is open to admit the gas to a chamber, and then this is the automatically closed to keep the pressure also. Okay, so this valve stem, it is also spring type of one spring. Here you can see one spring type of device we have to attach here. So this valve stem, it is keep the pressure in the inlet pressure, sorry, keep the pressure into these parameters also. So these are the valve stem, and this valve stem, it is basically classified into different categories. Most of the one is tubeless rubber snap type of valves. We have to use this. Another one, number two, high pressure tubeless snap type of valves, and also high pressure metal clamp type of valves. These are the three types of generally we have to use as in valve stem. Okay, that is tubeless rubber snap type of valve, high pressure tubeless snap type of valve, and high pressure metal clamp type of valves we have to use it. So these are the four main apparatus we have to use in the control valve assembly system. This is the valve actuator, positioner system, valve body, and also valve stem. Okay, is it clear all of you? So one question, it is also coming in your semester questions, that is a what is the basic configurations or what is the basic instrument we have to attach in this control valve system, and broadly discuss. So you have to draw this image also, and also you have to discuss one by one system. Next, in this diagram, we have to classify this actuator according to the operating mode. So here you can see these are the two types of operating modes, and also it is also linear type of valve. There is a linear motion type of control valve, air to open and air to close. Okay, so this is the pneumatic type of device, pneumatic controller type of valve, and it is also linear motion experiment also, which is dependent on the air, which is held to the open to the valve also, and another one is the close to the valve also. So here you can see this is a spring type of valve, and it is a one tube channels we have to attach from the pneumatic, the air pressure we have to inlet in this valve system. Then this is also pressing these systems also, and here also load we have to attach over here. So this is a basically ATO, that means the air to open and fail closed. This is we have to represent ATOFC. So when you have to working any industry, here you can see these are the basically short terms. These are the ATOFC. That means air to open or fail closed type of valves we have to work in that part. And here stem extends on the loss of air pressure also. Another one is the ATCFO, that means the air to close, that is fail open. Here you can see these are the basically vice versa systems of this air to open. Two springs I have loaded it here, and load is upper part and air is the pneumatic valve we have to attach in this tube also, where air is controlled the close to the valve also. So this is a basically one examples of the linear operations of the actuator operating system. Okay, is it clear all of you? Is it clear? No one is response. This is a another same type of, that is a air to close well open type of linear control valve. Another one is the air to open well closed type of valve. First you have to see air to open well closed, this type of, then air to close well open, that is the another type. Same logic, same logic, and it is uses the pneumatic type of operations also. Okay, so these are the different configurations we have to working in the linear valve actuator operating mode. ATCFO, that means air to close fail open, and it is a direct push down to the closed system. Another one is the push down to open system, that means ATOFC, that is a air to open fail close type of valves also. Next, another one, rotary type of valve. So we have to classify it into firstly, that is a one rotary type of control valve, another one is the linear type of control valve. So here you can see this is a basically examples we have to attach, that is a rotary type of valve. Okay, here you can see this is the rotating device. These are the basically rotating device also. Okay, this is the direct actions, which is a spring we have to attachable here also, and one lever which is connected to the rotating device also. Okay, when this device is positioned this position, this is the open condition, and when it is moved to this position to this position, that is called the closed of the operation. So this is direct action, another one is a reverse actions also. Okay, so in this part you have to connect it either this pattern or this reverse type of. So this is called the CCW to open ATC FO, that is a push down to close. Okay, another one is a CCW to open. So these are the same thing, same. That is a one is the direct action, which is open the control valve this type and this type, and also we have to rotate the reverse action. When this position it is this position, it is a closed position. When it is moved in the towards, this is the open position. So this is the rotating device of actuator operating systems we have to attach in this system. Next, valve positioner, and I am discussing the previously what is a valve positioner system. And here you can see this is a basically valve positioner. It is a air relay which is used to between the controller output and the valve diaphragm system, and it assures exact positioning of the valve stem in the accordance with the controller inputs also. So this is a two circuits we have to here seen, that is a single seated control valve without positioner system, that is the air to close system. This is the one valve, and here also spring type of one single seated valve we have to attachable here. Another one, this is the one another valve, it is control the air pressure. This is the air pressure limit, that is a 20 psig. Another one is that this valve, it is control the pressure 3 to 15 psig. This is a basically single seated control valve without any positioner system. And another one, when you have to use the positioner system, that is a single seated control valve with positioner. Also, it is air to closure system. So here you can see this is basically one positioner system we have to attach, and here these are the one channel, this is the another channel, this is the another channel. We have to attach into this positioner system. Okay, so using this positioner system, you have to control the pressure into the valve actuator system. Sometimes it is also working in the pneumatic operation. Sometimes it is also uses the analog input type of operation. Another one is also digital type of operation. So in this picture here you can see this is a basically one circuit diagram or line diagram when you have to work any industries. Okay, when you have to work any industries, you have to this type of diagram you have to again and again see that. So these are the basically the layout diagram of the any valve position or valve actuator system. Okay, so according to follow this diagram, and here are different types of value you have to see that according to this value we have to classify the different positioner system, different actuator system, what is the basic classifications, what is the basic rating of this system. Okay, so these are the basically valve positioner systems. Is it clear, all of you? Is it clear? Ravi Kumar. Yes, sir. Yes, Shibham Jaswal. Next, this is a one graphically representation of the flow characteristics. Okay, so this relationship between the valve capacity and the also valve stem travel, it is known as the valve flow characteristics of the valve. We have discussed in previous slide also. There are four components importance, that is the actuator system, one is the positioner system, one is the valve body, another one is the valve stem. So in this diagram you have to see this is the basically one relation between the flow position system, another one is the steam position system. Okay, so this x-axis we have to denote here steam position, and y-axis we have to represent that is a flow position. That is a percentage 0, 25, 50, 75, 100, etc. And this is also the same positioning system. This is also equal divisions 0, 25, 50, 75, 82, and 100 also. So this is a basically linear motion. When you have to any inputs you have to given, you have to graphically plotted. This is a basically linear motion, and this is a quick opening valve. When any valve we have to attach which is quickly operated, either it is also pneumatic type or electrically type or any hydraulic type. This is a quick opening system. These are the basically graphically representation here. Green line, there is a quick opening, and this is the equal percentage. Okay, this is the basically the curvature equal percentage. That's the value. Here you can see this is a linear motion, center point is 50%, and also this is the equal percentage is a little bit 82% of the values of the same position system. So these are the relationship between the control valve. One is stem positioner system according to the flow positioner systems also. Next, this is a one another. Just wait 1 minute. So in this slide here you can see this is the basically selection criteria. What is the selection criteria when you have to any valve it is selected or not? So in our corresponding different categories, we have to use this selection criteria different oriented. Okay, that means first we have to uh, discuss that body size and also flow capacity. Okay, so this body size, according to this body size and also flow capacity, we have to uses different types of application oriented in the different operations in the different control valve. And then also connections, end connections. Okay, then number 3 you have to follow the startup leakage. That means you have to particularly particular application oriented, you have to use as one definite type of control valve which is perfectly leakage proof. Okay, that is a startup leakage also. And according to the selection criteria, that is actuator sizing, we have to select the different types of control valve. Valve, then number 5, valve assembly material. Which type of material we have to use this valve assembly type of material. Number 6, these are the packing selection. Okay, these are the different criteria when you have to uses different types of control valve in our process control industries. Then these are the basically valve accessories. These are valve accessories means that is a actuator, positioner system, valve body, and also stem body, valve stem body. These are the different accessories, valve accessories we have to when you have to in select of the control valve in our application oriented. Then we have to also control the special type of requirement of the devices. We have to use a special requirement. Then noise calculation. That these are the another big uh, advantage or disadvantage also in the corresponding application oriented valve. So when you have to use this different types of control valve, you have to follow the noise calculations also. And last one, that is a quality requirement. So according to this quality requirement, what is the basic idea, the basic application of the control valve, and the parameter which is which type of parameter we have to use is certain other fluid or any specific gravity type of fluid or viscosity of the liquid. According to the uses, we have to select the quality requirement. So these are the basic selection criteria of the control valve. Okay, body size and flow capacity. Number two, end connection. Number three, start-off leakage system. Number four, actuator sizing. Number five, valve assembly material. Number six, packing selection type. Number six, that is a valve positioning system. Number eight, special requirement. Number nine, noise calculation. Number 10, quality requirement. Okay, is it clear, all of you? Next, sorry. These are the basically interface with other sections or other departments. Okay. So when you have to use it, any type of control valve in our process control industries, you have to select the different, that is the process, then also piping, then also electrical system. Okay, this is a process for sizing of the valve. Okay, and also you have to follow the for process conditions, which type of process condition we have to work in this process control system. Then piping system for face-to-face dimension we have to follow, for PDS to envelop the supporting system also. That is a PID, that is a proportional and integral derivative type of system, that is a PID controller markup system. We have to follow the piping system. And electrical, for electrical actuator power supply, that is a solenoid valves, we have to use this the electrical type of systems also. So these are the basically interface area which is connected in the any control valve in the process control industry. Okay, so everyone write your own name and roll number in the chat box also. Shivam Jaiswal, are you hear me? Shivam, are you hear me?
Yes.
Shivam, you take a screenshot right now. These are the basically attendance purpose. Okay, and after ending the class, you have to send me my WhatsApp. And I have another class. Okay, so after 2 minutes, all of you please join again. Next, these are the basically applicable codes, okay, or globally standard codes we have to use this in our process control industries for the control valve. Okay, so these are the you have to just see these tables also. So this is the basically different codes according to their uses of the control industry. Okay, process control industry. This is ASME B1634. This is the one type of valve. These are the basically flank type, threaded or welding ends also. So these are the basic codes globally or international. We have to standardize codes we have to follow when you have to use this, when you have to working in the any process control industries. You have to see these different types of codes also. Okay, these are the NFPA 7, the National Electric Code. So these are the different codes we have to use this process control industry. Okay, so everyone please write your own name and roll number. And please, all of you please join after 2 minutes. Again, we have to, again, one class is also present.